Okay, similar triangles.
I mean, yeah, it's for everyone. You can have it.
Okay, listen, if two figures are similar, what can you tell me about their corresponding angles? Congruent. What about their corresponding side lengths? Proportional. The figures are similar, right? So we have congruent, whoopsie daisy. If they're similar, there's congruent corresponding angles and proportional. Not congruent sides, proportional sides. They could be congruent, right? Okay, so we'll be setting up some proportions then to perhaps solve for missing side lengths, right? So what we'll have to do is think about how to figure out what parts correspond to what parts, right? And we'll use, congruent marks, right? You use like your angle congruence is like a single, a double, and a triple little arc, right? So you'll use those to kind of navigate around the figure if it's kind of confusing, right? So in this first example here, they want us to determine the missing values given that what? The triangles are what?
Similar.
Similar. It means corresponding sides are proportional, right? Well, let's get some angles in here so it'll help kind of chase things around here. So first of all, we know that angle A goes with what? So let's mark those with a single, right? And then B goes with, right? Use a double on those. And then, of course, C, and these are vertical. You see, BCA and DCA. I'll use a triple, right? So now I can kind of see go between. So I might want to look at, okay, this side here, 3, is between the single and triple mark. So what does it go with in the other one? What one's between the single and triple angle mark? Y. See what I mean? Okay. So they're going to first solve for Y, it looks like. And they're going to do small over big. What?
So does
BC would go with, say it again? CD. Double, triple, yes. See how you do that? Yeah. Especially if you don't have this readily available, right? Up here. Okay. All right, so they're doing small over big, right? And they're ready. You might rate S over B. That way, some of you had some trouble getting them switched. Yeah. Yeah. Okay. Could we also do big over small for our ratio? Could we? Yeah, we could. We just got to do them both the same, don't we? Right? That's all right. All right. So 2 here goes with 5. Willie pointed out, right? And the Y we have here, right? What does that go with? The 3. So small over big equals small over big. You know how to cross multiply, right? You get a Y of 7.5. And they're doing small over big again. Let me ask you this. If I want to do big over small, this would just be what? 5 over 2 equals what? Y over 3. You cross multiply, won't it work the same? Right? Let's just do that real quick. So let's do big over small. 5 over 2. It's a horrible 5 here. What the heck just happened here? Where do these things happen? Big over small would be 5 over 2 equaling Y over 3. Cross multiply. What do you get? 2Y equals what? Same thing, right? Okay? Doesn't matter which way you start. You got to go the same for both of them, okay? And then for X, the same thing. You get your corresponding lengths and set them in a proportion correctly, okay? Let's go down to this next one. It says the 2 triangles are similar. Well, they don't give us the similarity statement, do they? So we can't use that to figure out what goes with what. So here's our angle marks. So they got their goofy little things in here. So let me just do that. That's, remember, whatever software they use, they can't make these marks. Yes. So double, and then these guys on do triple. Okay. So if we wanted to go after the X here, what does this side X go with in the other triangle? Right? This is obviously a reflection, but if it's between the single and double, right? Okay. So now you need 2 other corresponding that have numbers in both of them, right? So you might be wondering, okay, how do I know to pick these other 2, right? How do we know to pick 4 and 5? Well, if we're using an X for one of the pairs, we can't have another variable for the other, right? Or Can't solve it, right? So if you're going after x, your other ratio has to have two numbers in it, all right? So 4 obviously goes with 5, and then we cross multiply, okay? You getting the idea here? You set up your proportion by, you know, a lot of these, they'll start, there's a couple that are really confusing. You're going to want to put these marks in there, okay, to figure out what goes with what. All right, let's go down to this one. We have to be careful with these here, okay? So given triangle A, B, C, and AD are similar, find the missing values. Could I do the following? 2 over x equals 1 over 3. Will that work? Does 2, this side of the small triangle, correspond with BD here, this x? Okay, so you're telling me that this segment here that x is on is the side of a triangle, is it?
Yeah.
Ah, it's not. It's not the, you need the whole side, don't you? You follow me?
So it's 2 plus.
Yeah, well, I prefer x plus 2. Correct polynomial order, right? That's okay for me.
I don't even know.
Oh, that's why we have the Google. So we need the whole side length. And again, over here, what would this side length be in the big triangle?
3 plus
4, right? You got to be careful with these. If you're going to do corresponding sides, you need the entire side length, okay? So now if we're going to set something up for x, and again, they're doing small over big, so 2 over, we need an x in it, right? We can't do over x. So in other words, so AB corresponds to A what? D. Okay, be clear on that. Equals, let's go to the other side where we have numbers, 1 over 4, okay? So I wish I would do it more vertically, right? So 1, we did, you know, they don't have to have the parentheses. 1, x plus 2 equals 8, subtract 2. Simple enough, right? Okay? So what they did over here, they illustrated what I did. They just took the two triangles and broke them out so you can kind of see how this side is. Why, see, look at that. X plus 2, they did it. Jeez. Okay. Now, what about 6? Is 6 in a whole side? That's a whole side. This 4, when we add them up, that's a whole side, and over here is 1 as well. Okay, so you get the idea? If you're going to compare corresponding sides, they need to be full, whole, complete sides of the triangle to do this right. So let's go over the other page here. We got some exercises.
For 1 next to it,
Yep.
it's the same thing.
It is, yeah. They just took this diagram and pulled the triangles apart. All right, so you can see what the entire side was in one of them. All right, Benjamin? All right. Okay, so let's take a look at this I'll kind of walk you through a little bit, and then I'll turn you loose on the rest of these, okay? So we've got 2 similar triangles, and how many variables do we have in here?
2.
2 of them, an x and a y. So we're going to set up some proportions to solve for them, right? Olivia? Okay. Let's get our angle marks in to help us chase things around. So that goes with that, right? Then this guy here to that guy. And of course these, by the third angle theorem, don't these have to be congruent? Remember the third angle theorem?
Yes.
If 2 angles in one triangle congruent to 2 angles in another triangle, then what? The third angles are congruent because they both pairs have to add to 180, right? Okay. Well, let's set up a proportion for x. Let's do small over big. I recommend doing this, especially in the beginning. Put S over B. If we prefer B over S, but then you stay consistent, right? So let's get something with x. Where's the x? Right here. Okay, x is on the big one, right? So what's a corresponding small side length? How do you know?
3 over
See this between the double and triple, and that's right. So let's do small over big. What over what? 10 over x. Well, what do I pick for my other ratio? I need corresponding sides with numbers. So give me 2 corresponding. Small over big, 16 over 24. There we go. Okay. So now we just cross multiply. 16x equals 240. Right? X equals 15. Okay? See how this algebra looks? Nice and neat, vertical, okay? Equal signs. What's that? It's preferable. There's times when you can go out horizontally. You know, like there's not another some
We
kind of
also
things.
gotta get the Y.
A few things lend themselves to horizontal work, but most of the time vertical.
We gotta get the Y out either.
We're going to get that right now. Thank you for reminding me. Let's do small over big now for Y. Okay? So there's our Y. Y is in the small, right? So I'll just do Y over something equals something over something. What does Y go with? 18. Can we use the same 16 over 24? We might as well, right? It's the same thing. So they're all in the same ratio. 16 over 24. Okay? So we get 24y equals 288. And we're going to do that in your head. All right, what is it then? What does y equal? Well, there we go.
I'm not.
All right, so that's what these should look like. Okay? So everyone take a couple minutes and do these last two. Be careful on that last one. What do I mean on this last one? What do you need to find before you get started?
The whole.
Full side lengths, right? Okay? So let's take a minute. I'll give you positive and negative whole numbers.
That's what I thought. It wasn't an integer. That's
Not
why.
12.
Okay, let me mark these up here. Whoops, doing that again. That to that.
I didn't do, I didn't.
No, they got started.
But you're going to do more than
Here, what?
What's next?
Hey, can I ask you guys a question? These angles right here, are they vertical angles?
No.
No, they are not. Okay? Almost look like, but they're not. All right, so for X here, I'll do small over big for X, right? So if I do 15,
Oh, we have to find the y. Thank you.
yeah, find them all, equals 12 over, well, this other 15, right? So we get 12x equals 225. Okay. So for y, I'll do small over big again. Whatever, it doesn't really matter.
I got 16.
So that is 16. Y over 20. And I'll do 12 over 15 again. 15y equals 240. So y equals 16. Okay? So let's see if we can correctly get number 3.
Yeah.
No, like,
Pretty confused. Where did I lose you?
Oh, because I took the wrong side.
So you did big over small?
Yeah.
You can, but you can, it'll work, just as long as you do it for both. So like this one here, if you had 20 over y, you just need 15 over 12 here.
Yep.
And it'll still work, right?
It's not for real.
You can do it either way. You got to do it the same for both sides equal sign.
It's not for real.
Okay?
Three.
Well, let's look at this. All right, quiet down. Quiet down. We got to get this straight. There's going to be a ton of them like this. So these triangles are laying on top of each other. So 8 is the full side in the small triangle. Does that go with 2?
what
Does 8 correspond with that segment 2?
No.
No, because that segment 2 is not even the side of a triangle, right? So what is the full side of the big triangle?
10.
10. We better do it over here as well. What's the side length here?
X plus
X plus 10, right? Okay, let's get after X. If we do small over big. Okay, let's go after X. So X is a part of which triangle? The big or small? Because, right? So wouldn't that go here? X plus 10. What's the small corresponding side with X plus 10? 10. And now we need 2 corresponding sides that have numbers in them. So we can't use y and 15, can we?
8 over 10.
8 small over 10. There you go. Got it? Now we cross multiply.
times 100.
All right, then, you're gonna go far.
Yeah, that's
Distribute through, 8x plus 80 equals 100. Subtract 80 from both sides. I see a lot of people trying to divide at this point here. You don't, no. You get it cleaned up first, see, right? So remember order of operation PEMDAS? When you're solving an equation, it's reverse order of operation. On the side method. I don't know. So x equals 2.5.
Wait, if I do big over small for y, do I have to do big over small for x?
No, they're separate things, right?
Okay, that's what I thought.
Right. Yes.
I did it in way different ways, so I could change.
What did you do?
I did 2 over x minus 8 over 10.
2 over x minus
8 over 10.
8 over 10? Why minus?
There's no way you got the right answer.
No, I did.
You mean equals?
Yeah.
Oh.
All right, so here's, okay, listen. There are, all right, I know what you're driving at. There are times when it'll work, if we're going to work. Listen, this is kind of important. I'm glad you mentioned that, all right? And you must have had an equal sign in between.
Yeah.
Okay. There are times when we can do this segment to that equals this segment to that one, right? And that's only going to happen when, say, these two segments are parallel. That's the only time that'll happen. Then and that's going to, when we get to the side splitter theorem, we can use that, right? But not always. It's only if you know they're parallel, right? So in this case, it happened to work out correctly. But you have to understand, though, if it's not the case that they're not parallel, if they're not parallel, then what you did won't work out, okay? So in the absence of knowing that, when we get to it in another section a little later, you need small side to corresponding big side, okay? Because a lot of times what will happen, well, and they did it here, right? So if you're going to go after y and 15, you sure can't use 2 and 8, right? See what I mean? Because that won't work there because y and 15 are full complete sides. And those, does that make sense? So you have it, sometimes that will work, right? If they're parallel, but they're not. So like that's kind of a coinky think that you got that right. Okay? All right. But you'll see when we get to that stuff later on, hopefully you'll see the distinction there. Okay? All right, so what do we get for y? Okay, 12. So if we do small over big, right? So we do y goes with 15.
Ooh, smells good.
And we need numbers, right? So small 8 over 10, right? 10 what? Yeah, 10 y. Whoops. 120, 10. Okay? Let me fix that.
What are accents in your picture?
I think it's 12.
12.
Oh my god.
Okay, let's
On your what?
have some of these regions. There's quite a few of them here. I have to ask you a question. Hopefully you read it.
Same.
You're probably thinking, okay, just like the other ones, I'm going to set up a proportion here, right? But what did they tell you in those other ones in the notes?
That the
That'll-
angles or the
Yeah, okay. They told you they were similar. That's how you knew a proportion would be the way to solve it, okay? Do we know that these are similar?
nope.
So technically, we kind of have to figure out why they're similar, or if they are, so we can set up a proportion. See what I'm getting at? Okay? Now, if two things are similar, what do you know about all the corresponding angles? Congruent, right? So let's check that. Let's check the corresponding angles.
Well, we have
We got 65.
vertical angles.
Okay, that's true. So we got these congruent. There's a pair that's congruent for sure. Got those in the bag. Hey, what's the measure of this angle here?
150
How do you know it's 65?
plus 180 minus 115.
180, they're linear pair, so that's 65. There's another pair.
And a 2 angle.
And then we got the third angles, right? Okay. Right? Like that. So all 3 angles, now we know they're similar technically. Now we can do our proportion stuff, okay? So we want the length of CB. And what I would do instead of writing CB, where's CB? I would just put an X in there and set your proportion up with X instead of having to write CB every time, okay? There you go. Anybody get an answer yet?
No.
Choice 3?
Right, please.
No, it's both.
Just take our time. Slow it down.
Well, if you're still working on it and you get 16.2, you got it right. I'm going to set up a proportion. I'm going to do big over small this time, just for kicks.
That's actually not bad.
Big over small. So let's see here. X, big, goes with what? What does the X go with in the small one? 7.2. And now we need on the other side 2 numerical values. What would they be?
21 and
21.6. That's a weird 6. And 9.6, right? So now you probably want your calculator, right?
Yeah, it's
Get
scary.
9.6x,
I got 3.
155.52.
it's not that bad.
Okay, we all good with that?
No.
You're not? Where are you hung up? Just button pushing time?
No, I'm trying to figure out how I got 207.36.
Well, that would be an error.
We didn't put the wrong number.
In this one, before you get started, I want you to think about, are the 2 triangles similar? He says yes. I want to know why.
I say yes. Because there's the right angle, and then it says that AC and DE are parallel, and it says that AB in point E is on TV.
Okay. This is kind of key. These guys are parallel, right? Right? So that's a right angle. If these 2 lines are parallel,
Alternate and terminal angles.
well, I think you mean to say corresponding angles? Wouldn't that also be a right angle and therefore congruent?
Yeah.
Do they share an angle?
Indubitably.
Yeah, do share.
And do- yeah.
That is B.
And
No, I just think to figure.
again, either the third angle theorem or corresponding angles, wouldn't these be congruent? So now you know for sure why the 2 triangles are similar, because all the angles are congruent, right? You got me?
Yep.
Okay.
Oh man, I'm not looking forward to
So let's put stuff in here. AB is 15, so we're going to do like a
What does school checks on tomorrow?
15.
Probably going
I
to.
feel like
BC, shh, this whole side is 12.
I think if someone died, the whole guy.
Better. EC, where's E and C? Oh, EC is, that's 7 right there.
Oh,
Seems like we need the length of EB. Any thoughts on how to get the length of EB? 12 minus 7, right? Which is 5. And they want the length of BD. So let's put an X here. Okay? So when they give us information, just get it all in there.
I think it's fine.
To record. Choice 2, she got 6.25. Okay.
I think it's fine.
So I'm going to do X, which goes with 15, hypotenuse is right, equals 5 over what? There's not even 10 on there. 12. Right? Okay. So we get 12x equals 75. 6.25. That's what you got? You said, right? Okay. So that method will work, right? I guess maybe I just didn't want to confuse anybody this point, because we'll touch on what you did a little later as well. Yeah.
So
next question.
for angle B, what is the corresponding angle? Oh,
They share it, so angle B congruent to angle B reflects the property. Yeah. Okay?
Oh, dang, there's a lot of.
Yeah, there are. So what does that tell you about this particular topic?
And it's super important.
All right, let's read over this one. Let's think about first if the triangles are similar. Okay? Think about if they are in fact similar. And then we can get our angle marks in there. I'm going to start marking things they tell us. So BD is 5. So that's 5. DA is 12. BE is BE is 7. Right? 7. Okay. They want the length of BC. Oh, they're kind of asking this in the converse, right? You see?
I don't like anything out there.
Well, they want to know length of BC so that these two segments are parallel, right? Remember, like if lines parallel, these angles congruent. Now they're saying, okay, what's going to make these angles congruent to get the lines parallel?
Well,
BC.
No, I didn't see that.
So we'll call this X.
so let's put x over 17.
X over 17?
Yeah.
You sure?
And
Where's 17 come from?
5 plus 12.
Okay, you're doing like she did. Let's just stay corresponding. Let's do this. Let's do small over big, whatever.
I didn't think it was small.
All right, let's do big over small then. Fine, doesn't
We're
matter.
gonna confuse
It doesn't matter.
Or it's just like,
So big X. So
Just want to know.
this side of the big triangle X goes with what side in the small one?
that one.
7 equals big. What's this over here? So 17 big over what? 5.
5.
Okay.
Where are you going? This one.
What's the matter?
Yeah, I was on the
We're setting up corresponding sides. So what do we get here? We get 5x,
119.
and what does x equal? Or what?
23.8.
23.8. Well, so why does that work, right? If that's 23.8, then the triangles are similar, right?
Yeah.
Which makes all their corresponding right.
Yeah.
So all the corresponding angles are congruent, right? And if these corresponding angles are congruent, then the lines are what? There, you see how they X that backwards, okay? This one, okay, this is the one where kids will just they'll get their knickers all twisted up, and okay, because these are not oriented in any kind of way to like intuitively see what goes with what. You're gonna have to rely on your angle markings, okay? Big time in this one.
Okay.
I'll go ahead and do that. So RD is 4. RO is 6. OH is 4. So I'm probably going to need this, so that's going to be 10, right? Okay. And are there any angle congruencies in here? See, probably you guys like to skip reading things, but that's kind of important, right? So angle H congruent to RDO. Any other angle congruencies we can determine in here? Do they share an angle?
Yeah.
Yeah.
Okay, reflexive property, put a double mark there. What else we got?
And then,
C, and then I don't know.
Well, okay, angle C, there's only one other angle in the other triangle not marked. What would it be? Angle what?
DOR.
DOR, there we go. You see, now we have our angles marked. Now we can navigate around and get our proportion. What is it they want us to solve for? CD, let's call that X. But again, we're going to need the full side of a triangle, aren't we?
Yep.
So what's this? Okay. All right, take a minute then and set that up properly. So if I'm going to do small over big, I need the X in there. So X plus 4 is the big side. What's that go with in the small triangle? Okay, so X plus 4, let's figure out how we know that. So this side X plus 4, it's between the double and triple marks in the big, right? Where are the double and triple marks in the small? So what goes up here? 6. You see how I, right? You guys get that? You follow me?
Yeah.
I need my X to solve for, right? And I see that my thing in the big triangle is between the double and triple. What, how do I know where, so double and triple in the small is a 6. You get the idea?
No.
Why you hurting me, Brandon?
No,
Lily, do you see this x plus 4?
Yeah, but I thought the 4 was the small.
It doesn't correspond. Look, this x plus 4, you see this triple angle mark
Uh-huh.
and this double angle mark? It's between the double and triple angle marks. Now look at the small triangle. What number is between the double and triple angle
The
marks?
ones on a triangle, that's what confuses me.
That's how you know. Okay, so what goes on the other side then? Small with some number. That'll have a big with the number as well.
4.
4. Well, 6 is back in the triangle, right? So that's between, see, 4 is between a single and double. What's between the single and double here? 10. See, it's complicated. If you don't have those angle marks there, it's going to be tough. Okay? There'll be another one like it. You'll get to try, so don't worry.
I'm trying this one, but my brain.
So,
This week more.
Oh my god, it's 2.
how many got 11?
I had it right the first time, but I went stupid halfway through it.
Good job,
Go
Ryan.
stupid, go crazy,
Um,
Actually,
Okay.
do it. You know?